The interesting ones are these interactions between demographics of the respondent and the neighborhoods themselves. So on race, we find that for white respondents, blocks that had a higher fraction of white voters were more likely to be included, and blocks that had a lower fraction of white voters were less likely to be included. So this is demonstrating a preference for homogeneity, racial homogeneity by white respondents that we actually don't see from minority respondents. So this would be consistent with a lot of literature. What's interesting about that, well, I'll talk about that in a second. So we see a very similar, even more consistent story on the partisan front. So Democrats want to include Democrats and Republicans want to include Republicans in their neighborhood. And then it turns out a lot more mixed results for education. So not a lot of consistency across cities, although the one consistent pattern would be that college educated respondents seem to display sort of stronger preferences than non-college educated respondents for college educated areas. But again, a lot of heterogeneity. It seems like in New York and Phoenix, there's some affinity among college educated voters, but that's not present in Miami. So a little unclear sort of what's going on with this story. We unfortunately do measure education at a coarser geographic level due to limitations in the census data, so that could play into this as well. But what's interesting about this is, to me, not only do we find this preference for same party, for co-partisan and co-racial blocks, but this is after controlling and for where people live, right? So we already know that there's residential segregation, people move to neighborhoods that already look a lot like them, with people like them, and that's driven a huge amount of segregation, certainly in the United States over the last 50 years. And what's interesting is that even once you do that, and then you ask people in the area they've already moved to, already chosen to draw their neighborhoods, we still see at the subjective level these preferences for people of the same racial group and the same political party. So if anything, that's even these effects aren't massive, but they're still pretty surprising to us given the fact that people have already sort of self-segregated and even just choosing where to live. Okay, so you can do these estimates for the whole model. That's nice. You get the story I told you about, but another nice thing you get, because we're fitting this rich spatial probabilistic model, is we can actually zoom into individual respondents and apply the model to individual respondents. So here again is this respondent who lives in Fort Lauderdale, and neighborhoods outlined there in black. On the left, we're looking at the block the block level map for percent white, and then on the right is percent college educated. And so you can see already that this person has sort of entered their neighborhood on the southern portion there, sort of along a racial boundary that also sort of correlates with an education boundary. And there's sort of an education boundary here in the northeast of their neighborhood, a little bit of a racial boundary there, and these are also where their neighborhood are ending. So we might wonder, is this consistent with the story on the previous slide? The model was sort of looking at preferences for this happens to be a white respondent that we're talking about. So this maybe seems consistent. What we can actually do is use the model and have it predict, sort of run that process I outlined, and actually have it sort of build 1,000 different versions of what it predicts this person's neighborhood to be, based only on their demographics and the location of their residence. And then we can sort of compare that to the actual neighborhood they drew us. But what's interesting is you can sort of flip back and forth here. You can see this area in black that they actually drew, and how similar it is to the sort of set of predicted neighborhoods at the model. And you can see that there's at the very beginning I sort of showed you that there were some borders here that corresponded to major roads, and you can kind of see how the probability of a block being in this person's neighborhood drops off here at these borders, and also sort of along some of these education or racial divides. Better yet, so what we can also do is we can actually fit the model twice. So we do is, so to sort of help dive into this a little more, we fit the model twice, once with all the demographic, racial, partisan information, and once without that. We have a baseline model that only looks at geographic features, so spatial distance, parks, schools, but no race, no party, no education. And we can actually compare the predictions of these two models, the one that has all the demographic information, the one that doesn't. And that's a way of sort of teasing out the impact of some of these factors at a very, very fine geographic level. So that's what this is showing here. This center area, so blue areas are where the full model is more likely to include and the brown areas where it's less likely to include. So you can see sort of basically where there's strong colors here, that's where these demographics are coming into play and how the neighborhood is drawn.